We shall learn how to evaluate double integral and how to find area under the curve using double integration. From our previous study, we already know if we have to find area under the curve using single integration. Suppose y equal to fx be a continuous curve and we have to find area under the curve using single integration. Then the process is, suppose we take one small rectangular strip of width dx and length y. Now we know that area of this strip is length into breadth, so y into dx. Now if we split the region under this curve into small rectangular strips and add up all such strips, then we can find the area under the curve. So basically fx into dx, this represents this area of one strip, y into dx, where y is fx, and this integration gives sum of all such strips from x equal to a to x equal to b. So area using single integration is given by this formula. We already know this from integration from x equal to a to x equal to b fx dx. Similarly, we can find area using double integration. In place of y, if we take dy as length of the strip as dy and width of the strip is dx, and dy varies from 0 to upper limit is y equal to fx, and if this strip moves from this place to this place, then x varies from a to b. So limits for y are 0 to fx and limits for x are a to b. So this is the formula to find area using double integration. Next we find volume of surface using double integration, where z equal to fxy is a surface. We take small portion of the surface. Let the small portion is given by cuboid, and we know that volume of this cuboid is length into breadth into height. So this is dx into dy, dx into dy into height is dz, or here we have taken as z is fxy. So this basically represents length of the volume of the cuboid, and if we sum up all such cuboids, then we find the volume of whole surface. So that is given by double integration, where x varies from a to b and y varies from c to d. So these formulas we have already discussed. If we have to find the area under the curve using double integration, then we will use this formula, and if we have to find again area under the curve, the difference between these two formulas is when the limits of integration are constant, x from a to x equal to b, y from c to d, both limits of integration are constant, then we will use this formula. And when limits of integration are variable limits, so order of integration is dy dx and y varies from 0 to fx, where fx is a function which is a variable limit, then we will use this formula. Next we shall learn how to evaluate double integral using examples. We shall learn basic ways to find out to evaluate double integration. So now we have to evaluate this. The order of integration is dy dx. That means first we have to integrate with respect to y, and then we have to integrate with respect to x. Now first we have to integrate with respect to y. We will be integrating in the same way as earlier we have been doing using single integration. If we integrate with respect to y, then treat x as constant. So here first we integrate with respect to y, so we treat x cube constant, and x cube is same, and integration of ey using basic formula of integration of ey is ey. Now apply limits 0 to 1, apply upper limit, y is 1, so e1 minus lower limit, y is 0, e0 is 1. Once this integration is over with respect to y, then we integrate with respect to x. So integration of x cube with respect to x is x4 by 4, and then apply limits, lower limit, upper limit. So put x2, so 2 raised to power 4, by 16 by 4, this gives you 4, minus put x1 1 by 4. So and simplifying we get this. Next we have to evaluate double integration x square sin xy dy dx. Now order of integration is dy dx. So first integrate with respect to y, treating x constant. So integration of sin xy is minus cos xy and divided by, because we are integrating with respect to y and x is treated constant, so divided by x. And this x square is also as it is because we are treating it as constant. Now apply limit 0 to pi by 2. First upper limit minus cos pi by 2 is 0, minus lower limit minus minus plus cos 0 is 1, so 1 by x. And x square by x, this we get x, and integration of x is x square by 2, so this is, and apply limits 1 to 2, put x2, so 4 by 2 means 2, minus put x1 1 by 2, so 2 minus 1 by 2 we get 3 by 2. Next we have we have to evaluate this. So using same rule, first integrate with respect to y, treating x constant, so x as it is. Integration of y is y square by 2 under limit 0 to 1 plus x square constant. Integration of ey is ey under limit 0 to 1, and then apply upper limit, put y1, so 1 by 2 here, 1 by 2 minus y0 0, put y1 e minus y0 minus 1, so e minus 1. So here you have x square by 4 plus x cube by 3 under limits 1 to 2. If you integrate x square, integration is x cube by 3, and if you integrate x, then integration is x square by 4, and then simplify, we get this. Next we find area using double integration when the limits of integration are variable limits. So we have to find area enclosed in the circle in first quadrant. So we have to find area for this part of the circle. This is enclosed in the first quadrant. So we know this is a formula to find area, double integration dy dx. Now we have to choose one small strip in this region, and limits for y varies from 0 to the curve. On curve y square is 4 minus x square, so y is under root 4 minus x square. So y varies from, limits of integration are, because y is on the first quadrant, which is a positive quadrant, both x and y are positive, so we have to take positive limit of y. So y varies from 0 to under root 4 minus x square, and in this region we have to cover this whole region, है ना? So in this region this strip moves from this line to this point. So at this line x is 0 and this is the highest point. At this point x is 2. So limits for x are x equal to 0 to x equal to 2. Now first integrate with respect to y. So integration of 1 is y. So this is y under limit 0 to under root 4 minus x square. And apply limits, upper limit minus lower limit. And then we have to integrate with respect to x. So we know formula for integration of under root a square minus x square is x by 2 under root a square minus x square plus a square by 2 sine inverse x by a. So x by 2 under root a square is 4, a square minus x square plus a square 4 by 2 sine inverse x by a is 2 under limit 0 to 2, and then apply upper limit, put x2. So if you put x2, 4 minus 4 0, this part is 0. If you put x2, sine inverse 2 by 2, sine inverse 1, which is pi by 2. So 4 by 2 means 2 into pi by 2 minus lower limit. Put x0, x0 means this 0, sine inverse 0, put x0, sine inverse 0 is also 0. So we have pi.